thank you and welcome. Never a good thing to be standing between you and lunch, but it is an important talk, hopefully. You will get something useful out of it. How many of you are using GraphQL today? Okay, just a few hands. That's actually quite exactly the talk I was planning to provide a little bit extra context as well for those who may not be familiar. So what we're going to do today is we're going to start by talking about, start from something familiar, web applications, think a little bit about what we do, and then gradually compare that, kind of like a layer stack diagram, compare that to GraphQL, and try to give you a little bit of information about what does it feel to develop GraphQL application. Then we're going to look at the programming model that we have developed for Spring. And then we're going to close with a little bit of trade-offs so that you don't walk away kind of thinking this is all, you know, perfect. And as we know, there are no perfect technologies. There are always challenges that we need to address. So I think it's important to understand the, that side of things as well. Okay. So what we know about applications and web applications, what we're used to is, of course, REST. And with REST, the goal is to have many URLs, and those URLs represent unique resources, and we want those to be relatively fine-grained resources so they can be reusable for different scenarios, for different situations. And generally, having many URLs is kind of the goal. It's, that's how we expose value in REST. And it's key to flexibility and reusability. So we have many controllers, web controllers, and they handle each one of those URLs. Now, how do clients actually discover our API? In REST, there is no standard to do that. Actually, the idea is that you don't declare REST, in REST your HTTP API in full, and instead clients should use HeyDOS, and there are different maturity levels for REST to navigate from one link to another and discover that API. But what a lot of applications end up doing is kind of staying one level below that highest level of maturity level, and they use something like OpenAPI in order to declare what their API is, and that gives access to a lot of different kinds of tooling. You can have documentation, you can have testing screen, you can generate client code, you can have validation. So these are all things that in many situations they do make sense, and they're attractive, and a lot of applications use this. But there is no standard for it. Now, GraphQL takes a quite different approach from this. It's a more data-oriented approach, you might say, if you want to compare resource-oriented architecture versus data-oriented. And it starts with a specification around the schema. So you have a schema, and in that schema you have data types. These data types, you can express things like something is required, you have validation. So this is basically a standard in GraphQL. It's a specification, and around those data types you can have queries and mutations as the two main kinds of operations. And then there's also subscriptions, which is basically a way to get data in a streaming fashion. So once you have this schema and you have this strongly typed declaration of what your API is, you know, that schema exposes the data. You're now focusing on the data that you want to provide rather than, you know, REST, URLs, resources, going through all of that design. And instead, clients can make queries or mutations, and they can send, and you can see here an example of a query. And you know, on the first line there, it says that it's a query, and then you have the name of the query, and you can pass input arguments pretty much at any level in a query. The queries can be more nested. You can provide more data. And then also, what you see below that is what's known as a selection set. So you're sending the query, but also you have the ability to tailor the data which is coming back from the server. And this is kind of a key feature of GraphQL. So you can see here that even though the query user exposes all of this data, a user with a GitHub profile, Twitter profile, as well as the data on the level of user, you actually have the ability to say which data is of interest for this particular request. And that's kind of built into the language. Now, once there is a schema and the ability for clients to send requests, you can build an engine to do the initial parsing and processing, validation, is everything syntactically correct, is it valid? And also, such a engine, and these are language-specific engines, there's one for each language, for Java, for JavaScript, and so on, can do also all the overall execution. So, for example, GraphQL Engine can parse the query, it can see what data needs to be returned, and then for each piece of data in the graph, you can register what's known as a data fetcher, and that will return the data. So the GraphQL Engine can figure out which data fetchers actually need to be invoked. It might invoke them in parallel and then gather all the data and return it back to the client. So you can see how our diagram changed here. Back in REST application, you have the web layer and the controllers are handling individual URLs, and you're connecting things that way. Here, the API layer is actually one level down. First, we have an HTTP endpoint, and that's just a single HTTP endpoint, so it's just transport, basically, single URL. And then you have the GraphQL Engine doing a lot of the hard work of kind of driving the overall processing. And what the application can do is then register data fetchers, and these data fetchers are the API layer of the app. That's the first place where the application actually gets invoked to do what it needs to provide, to supply the data. It doesn't have to be HTTP, it can be WebSocket. So here we have an example in this diagram, WebSocket handler at the top, and that means we're using a single connection, multiplexing, any number of requests will come over that single connection, so that's kind of efficient way to send requests. It doesn't even have to be a web transport, so we have actually pretty good support for RSocket in the Spring framework, and it was quite straightforward to plug that in as well. And that means that it runs over WebSocket or TCP. And just as a quick aside, you might be wondering, I mean, if this RSocket over WebSocket, you know, what do we get? With RSocket, you get a lot of benefits for streaming. So if you're doing subscriptions and you're sending data and streaming that data, you pretty much get nothing out of the box with WebSocket for that, but RSocket has lots of goodies built around streaming, first-class streaming support. So we basically replaced navigation of URLs as a way of interacting with the server with data queries against structured data. And this allows GraphQL basically enables the application to be less prescriptive about granularity of data. With HTTP, you kind of really have to focus on designing URLs and make sure that everything is very fine-grained in order to be reusable. This is quite key for flexibility. But it's difficult to get that balance right. What is all the data that you're going to need? You have to understand that. Then there might be use cases that you don't know. And it's generally not easy to get that balance right. If you look at GraphQL, it basically has a built-in mechanism, and for a given query, you can focus on returning all the data which is applicable that an application wants to expose, and then clients can use the selection set in order to choose the data that they need. And this is one of the reasons why GraphQL has become very popular. Is because it gives clients additional control. There is no such built-in mechanism with REST. It can be done, but again, it's nothing that's built into it. And this is often something that's being pointed out, but I would also say that this is important from a server-side perspective as well. As you design the application trying to get the granularity right. Well, you can instead focus on designing the data and exposing that through the schema, and then clients can choose what they need. Now, this does mean that responses can be more coarse-grained. If you think about what we're doing here, one response can actually be the equivalent of multiple REST resources. So this is something which is powerful. It is another benefit of GraphQL is that actually you reduce the number of requests that you need to make back and forth in order to get the data that you need. But it also comes with certain consequences. A single URL request, in REST, it's fetching a particular entity, let's say. Well, you can have a HTTP status for that, and you can say, was it successful? Did it fail? 404, 403, and so on. But we're now fetching multiple different kinds of data, and there is no one single outcome that we can attach to it. Some parts may have failed, some parts may have succeeded. And this is why it actually always comes back with 200, as long as it made it successfully to the server, as long as it was parsed, the JSON was processed. Then from thereafter, it comes back with a 200 response. And if there are any errors, those are going to be in the body of the response. So this is an example of a successful response here. We're actually, in this query, we're requesting all the data that's available. And you can see on the right the data that comes back. You can imagine that this is actually coming through multiple, in REST, this might be multiple requests. You might make one request to get the user, then you might make another request to get the GitHub profile or the Twitter profile. Here, all of this can be exposed in the schema and fetched in a single query if that's what you need, but the client can also choose which data to bring back. Now, this is an example of what's known as a successful but partial response. The data came back, but maybe one part of it didn't. So you'll see down at the bottom, the arrow on the right is pointing to the null field for GitHub profile. So that's where the field was actually replaced. It was set to null, and it was replaced with an error. And you'll see in the error section that each error may have a path, and that path indicates exactly what part of the graph didn't come back. And so when the response comes back, you can check for a given field, if it's null, is there an error attached to that field? Of course, this does mean that the way you handle responses is now different. It's almost like handling multiple REST URLs and then dealing with all the things that may have come or not come. So yeah, those are some of the consequences of actually, getting this power. Okay, so now we're going to take a little bit more of a look on the server side. So we have the schema, and you have the query, a query in this case, and then there, all the data is below that. And you can register, an application can register data fetchers for any field. And even queries are considered fields. So you can think of everything as being types and fields. So the user query is also a field under the type called query. That's just the way it works in GraphQL. And so here we have a data fetcher registered against the user query, which makes sense. We want to fetch the user. Something has to, do that work. But then below that, you can go as fine-grained as you want. If you want to return a user object which has all the data in it every time, then you don't need to register any more data fetchers. But in this case, you might want to register a data fetcher against the GitHub profile field and the Twitter profile field of the user object, because first of all, those are probably coming from remote REST APIs. So you don't want to make those calls every time, and then they're separate calls anyway. So it makes sense to register a separate data fetcher for those individual fields. And you can see that the rest of the fields, they just get initialized from the properties of the object, the top-level object. So user has an ID and a name, and that's gonna get used. But you can see in the user object that we don't even need to have a GitHub profile or a Twitter profile field. As long as there is a data fetcher registered, GraphQL Engine literally just runs through what needs to be fetched and either finds it in the object that was returned at the top level or the level below, or if there's a registered data fetcher, it's going to invoke that and then initialize the field from it. Does this make sense? Okay. Okay, so now what we've done in Spring, so in GraphQL, there's literally an interface called data fetcher, and there is a programmatic API where you can register a data fetcher against the type and field. So that those are the field coordinates is what's known. So here we can register data fetcher against query, :user. Those are the coordinates for the data fetcher. What we've done in Spring is to introduce an annotation-based programming model. So instead of registering data fetchers directly, we do that on behalf of the application. But what you're creating instead is annotated methods. You know, you can think of them kind of like in a Spring MVC controller. But here we have, let's say, query mapping, and that is for the query type. So we're mapping to a query, and the name of the method by default matches to the query name. But you can use the attributes of the annotation to be more explicit if you need to be. And then we have the schema mapping, which is the general annotation. So that's kind of like the request mapping in Spring MVC versus get mapping, post mapping. In a schema mapping, we are going to determine the field name also from the method name. And as far as the type name, you can see here the user object being injected. Well, that's the parent, what's known as the parent or the source object, right? If you think about what the GraphQL engine does is it starts from the query and it calls the data fetcher or the controller method in this case for the user, which returns a user object. So now we've got a user object and we have to fetch all of its fields. So when it goes for GitHub profile, we can have that parent user object injected, so we can look at the information to see which user actually we're trying to load, and then we can make the remote call to GitHub or to Twitter and so on. So we take that parent type from the Java class, but again, you can override that if you need to change it. Yeah, so here it actually, what I was just talking about, the parent object, so the user method gets called first, that returns the user, and then that gets injected when the next fields are invoked below that. Okay, so that brings us to Spring GraphQL. So we'll take a little tour of the programming model of what we've built that's available. Hopefully you have enough of a picture of kind of what's going on here by now. Actually, any questions? Okay, we'll keep those for the end. Right, so we're building on top of GraphQL Java. We support running with HTTP, WebSocket, or RSocket. There is a boot starter, and all of this is available out of the box. You can just start writing data controllers. And they look like what I just showed you earlier. So now we'll take a look at what kinds of things you can pass into these controller methods. So one of the first things is that for a query, or even at any level in the selection set, you can actually pass arguments. This is a way to pass input in GraphQL Java from the client to the server. Or maybe you have a mutation, and the mutation obviously needs to pass input as well. So we need a way to take that input and then inject it into the controller method. Now, in GraphQL Java, there is an object called data fetching environment, which is similar to the servlet request, let's say. And from it, you can get the input arguments, but they can come as a map of strings and objects. So it's just basically the JSON input turned into a map of objects. There is no strong typing associated with that. Now, what we do there is that you can use the add argument annotation, and then you can have that object injected actually as the type that you want. In this case, it's just an ID, and we're injecting it as long, so there's a conversion there from string to long. But this can also be a complex argument. So it can be an object which has fields in it. And for this, we support constructor injection. So you can declare your object with constructor arguments, and those arguments will be instantiated based on what's coming from the input. You can also use setter-based initialization. So for that, we use data binding, which is very similar to what we do with form data for web requests. And this can be done at a nested recursive level. So you can have an object with constructor arguments, and then those objects themselves can be instantiated through constructors. So this all works pretty nicely in a nested and recursive fashion. We support standard validation, Java Bean validation. There is separately a project from GraphQL Java on validation which can be done with directives. So directives are like annotations in Java, but in the GraphQL schema, you can put directives for validation. If you prefer to use that, then you can express it in the schema. But you know, this being Java, a lot of times your objects might already have standard bean validation annotations on them. So this makes it easy to just say add valid and on any of the arguments on the method, and you're going to get validation. Okay, so this is, yeah, you can see up there the input that comes in. That's kind of a more complex object with JSON data. Okay, so in terms of the return values that you return, you can do a blocking call, and the GraphQL Java engine will invoke all the data fetchers in order, and it's neutral to asynchronicity. If your method is blocking, then it's going to do them one by one, and it's going to return whenever that gets done. So if you want to just use JDBC and return directly the values, that's fine. But you can also use reactive data fetching layer. You can use reactive repositories and return Flux or Mono. And this is nice because GraphQL Java will invoke all the data fetchers for the query. And we turn those into futures, which is what GraphQL Java engine works with. Then it waits on all of them. When the data is ready, it sends it back. So this can be done in parallel where it's possible. So that's much more efficient. And there is also an option that you can wrap the return value as a callable. And we will execute that through an executor. We will get it off the main thread. But in order for this to work, you do have to register that executor. So you have to configure in Spring for GraphQL the executor. And if you do that, then you can start using callable for your asynchronous, to make these methods asynchronous. There is one last option, which is interesting for managing the input data. So if you have, again, this is the same kind of input, like the search criteria from previous slides. But this is using a mechanism in Spring Data that allows you to annotate, just express in an interface what is the data that you want. And you don't need to create an object for it. You just label it as projected payload. And if you declare that as an argument, you will get that input without having to actually create an object with getters and setters. There is support for security. If you recall again the layered diagram, we have the web transport at the top, like HTTP WebSocket, then you have the GraphQL Engine, and then we have the data controllers, which is what we're looking at here, components like a mutation, for example, or a component invoked from that mutation controller method. So what we do is we make sure that your security context, let's say the Spring Security filter chain, that gets propagated all the way through the GraphQL engine and make sure that that's available. And we do support that with Spring MVC. You can run with Spring MVC or Webflux, and for both of these, you can use annotations like that to secure. You can also inject the principal, or in this case, you can get the user from the principal, extract the principal, and have that injected into the controller methods if you need to look at that. We have integration with Spring Data. If anybody's using Query DSL, so that's one option in Spring Data. Query DSL is a technology that allows you to prepare a query in a technology neutral way. So you can use Java DSL essentially to prepare a query. And this works well with GraphQL because we have built a bridge between GraphQL input arguments and Query DSL, meaning that we can take the inputs that are coming, we can look at the names, and then we can build a query as long as that matches the fields of the book object. And out of that, basically all you need to do is just, here's your book repository. It's a Query DSL repository. And based on the fact that it fetches a book, and based on the fact that that query returns books, it can be a single book or a list of books, a collection, this repository will be automatically registered. And you can override that if you, let's say, create your own controller method, or you can override so that this automated registration will not take place. But out of the box for queries, this is only for queries, we will register this repository because we discovered that, hey, this can return this data, and so it gets registered. So that's kind of a nice option. And you can do the same, and then once you have Query DSL, that works against JPA, MongoDB, LDAP is where it's supported currently. And another similar integration is with Query by Example, which is another technology where you can build, you can create an object, populate it, and then use that as the query. In a sense, you pass that, and that's what's used to then work against MongoDB, Neo4j, Redis, R2DB. And once again, if you declare this as a GraphQL repository and it's returning a type which matches to a query, then we will automatically register that, but you can override it again. Okay, so we get to testing. Testing was something that we provided quite early on, but has evolved quite a bit to the point where we are now. We have quite a few options. At the heart of it is the GraphQL Tester. So that's kind of your web test client that you're comparable to the web test client that you use with GraphQL, and it gives you a workflow for testing GraphQL requests. And in this case, how many of you are familiar with slice tests in Spring Boot? Okay, I see a few hands. Yeah, so that's a very useful technique where instead of instantiating all of the infrastructure or the entire, bootstrapping the entire application, you're indicating, let's say that you're focusing on one controller at a time, and then depending on what it is you're testing, like HTTP or GraphQL, then only specific infrastructure will get created. And the idea is that only that controller and just a few other things get instantiated in order to do a focused test. And then if that controller needs to call something, you would inject the controller with mock dependencies and so on. So that's kind of the philosophy behind the slice test. So we support that for GraphQL, GraphQL slice tests. There is no client involved in testing this, which means that when you get this GraphQL tester, it's going to work directly against the GraphQL engine. So that's a kind of server-side testing where there is no client, there is no remote calls or anything like that. And you can see in the API that we are declaring the request, and the way that this is done is by the query is actually in an external file. And that file is in source test resources. There is a convention there. There's a directory called GraphQL-test. And you can create GraphQL files with individual queries that you want to test with. And here you see another feature of GraphQL where you can have placeholders, these variables, and you can parameterize the query that way so that you can separately provide a variable, and then that variable can be different. You can execute the query many times with different inputs. There is in IntelliJ, there is a plugin for editing GraphQL files, and so you can be in IntelliJ creating these with, it understands the schema, you can do control space, and it will give you suggestions for what you can enter. So that's a nice experience. I mean, you can call document, and then you can pass the whole thing as a string, but it is a nicer experience, at least, until we get to, higher versions of the JDK where we can at least type it, a little bit more nicely with multiple lines. But this is actually a pretty good experience, creating your queries in external files and then just referring to those files by name, providing the inputs. Then we're going to do execute, and that's actually going to make the request. It's going to call the GraphQL engine in this case. It's going to do all the work. And when it's ready, we have a response. So now we can use these paths to indicate what part of the response do we want to examine. And the data which is at that path, we can then turn it into an object, and then we can, test what is the value there. So that's kind of very similar to using, let's say, web test client. We can do testing over HTTP. And for that, you can see here that we're doing Spring Boot test, and then we're indicating, just like we would say auto-configure web test client or auto-configure mock MVC, here we say auto-configure HTTP GraphQL Tester. And for that, we get a GraphQL Tester, so that's kind of protocol independent. Once you get the tester, it doesn't matter if it was created for HTTP or for anything else, but you could inject HTTP GraphQL Tester as well. And then we can start using that for testing. In this case, there is no server. You're going to be testing against, with mock MVC or the web test client, which means it's serverless testing, but it's still using a client. It's actually going through the steps of submitting this over HTTP, then the server processes it as any HTTP request. And of course, you can see here web environment random port. If we did the same on this slide, then you would be testing with the server running with an actual live port. We can do testing over WebSockets. Here we're doing a little bit more work, and we'll probably try to make this a little bit easier in boot. But essentially, we need with WebSocket, we cannot automatically create, I guess, we need at least a WebSocket client, and we need a URL that we want to connect to. In any case, it's quite straightforward, as you can see, to test over WebSocket. Now, with WebSocket, you also have a connection, and so there is a start and stop method. And you can, for example, in the context of testing, you'll probably want a teardown method as well, where you call stop in order to stop the WebSocket connection. But this actually becomes even more important on the client side. So we'll start with the HTTP GraphQL client. So generally, the philosophy for both the testing and the client, and they're very similar in a way, because they're both clients to the server in a way. But in one case, we're testing. So what we want to do with the response is a little different from what we want to do when we're a client. So the options are a little bit different, but generally the philosophy around them, and they're similar in many ways. So one of the things, for example, is you'll see that we support WebSocket and RSocket. And for each of these, there is a dedicated interface to actually create an instance of it. But once you create the client, what you get from there is the same interface, the same API for making the requests. So here you can see it looks a little bit like the tester, right? We're providing a document. So that's, again, a query which is loaded from a file. And I should also mention, actually, that you can pass the string, and in GraphQL, there are some tools that allow you to generate classes. So you can, for example, take the schema. We don't have that in Spring for GraphQL, but you can, for example, find that in Netflix DJS project. You can point to a schema, and then you can choose to have those classes generated if you want to. And it will generate Java classes for the query as well. And on those Java classes, you can say toString or similar method, and that gives you the serialized version of the query. And then you can pass that into this client. So you can use, on top of this, you can also use code generation. I should mention that. But yeah, generally the idea is whether it's HTTP, whether it's WebSocket or RSocket, you get the same interface, and then you can start making requests. But they do work quite differently, because if you imagine with HTTP, it's a one-for-one, one GraphQL request is one HTTP request. So that's a simple thing to consider. With WebSocket, we actually, when we want to make a request, the first thing is we actually have to establish the WebSocket connection if we haven't already. Then we have to do a couple of things over that WebSocket connection to get GraphQL ready. There is a mini protocol. So all of these things need to happen on the first request, and you could be trying multiple things at the same time. So this is a little bit more complex in terms of the implementation. But also, it's a little bit different in terms of the API. I mean, if you think about with HTTP, it's natural to say, oh, can I add some HTTP headers, for this particular request? Well, that makes a lot less sense when you think about WebSocket, because each request is over the same WebSocket connection, which gets established in the beginning. So to make this kind of a consistent story, you deal with all the transport-specific details in the beginning. So you set up your web client, and this create method, you can replace it with a builder, so you can do some more advanced things there, add HTTP headers. And if you need to change the HTTP headers, you'll create another instance of the client, and you will give it different headers, let's say, different authentication maybe. So all of these differences are dealt with at build time when we're building the client. But once we have the client, it's always the same interface. Now, what is interesting about this here also, there's a lot more about the client. When you get the response, if you remember, there are these field-specific errors. So here, we're not bothering with that. We're just saying, give me all the data, turn it into a user, and you get that back. But if you wanted to, you could drop down on the level of actually looking individually, field by field, or if this actually has some error in it, it will raise an exception, and then you can check that exception, and you can start examining field-specific data. So that's kind of a thing that's more specific to GraphQL, where, again, the data that you get is more composite. It isn't more like REST, where a single thing either succeeds or fails, and all the data is in it. So there's lots more options in there. Right. So before we close out, just a few thoughts. Yeah, we'll come back to questions shortly on architecture. So first of all, GraphQL does provide some new capabilities and does give some extra power. And that power essentially is given to the clients, and this is why it's so popular, because they can do things which are not easy to do with REST. They can select what data they want. They can customize their, needs for the scenario, and servers can expose things that clients can use in ways that were not anticipated or expected. That's extra power, and that's very important. But of course, this power comes with new challenges. So often it is easy to look at this and say, "Oh, this is great," and get all excited and exhilarated, but there's always a catch, right? There's always things that, consequences of those choices and that power. So one thing, I'll just mention a few things, but schema design is hard. I mean, there's lots of tools out there that will take a database schema and then they will produce GraphQL immediately. That is probably the one way you can shoot yourself in the foot with GraphQL. I'm not going to say that it's always the case 100%, because sometimes maybe that's exactly what you want, but it's very difficult for me to imagine that that is, in most cases, something that's going to work really well. So there is a process by which you actually need to think quite long and hard about the data that you're exposing. It is not an easy thing to do, but that has nothing to do with GraphQL. That has to do with just generally data modeling and design and making decisions. You can imagine multiple groups in a company trying to come together and agree on a common schema. So that has its positive benefits because it promotes communication, and people who are non-technical backgrounds can participate in that conversation and they can use the same language. But there's no two ways about it. The quality of the schema, the amount of time that you spend in creating a schema is going to be directly proportional to how successful your experience is going to be with GraphQL. And this is a learning process, right? Like it's not something that your first schema design that you come up with is going to be ideal. Second of all, as we talked earlier, coarse-grained data brings new challenges. If you're fetching more things, if clients can ask for more data, that means on the server side, you have to anticipate all the possible things they can do. Now they can ask for a lot of data, and you have to figure out how to not overload that database. You have to figure out, you know, all the joins, and so that creates more of a burden for the backends to handle this and to do it efficiently. It does have implications for error handling because you're getting multiple things. Some of them may be there, some of them may not be there, so that complicates a little bit what clients need to do. And there's also the question of caching. With HTTP, you have fine-grained resources, and proxies and clients can do caching based on HTTP spec, and there's lots of facilities that are built in at the infrastructure level. In GraphQL, there isn't anything that handles caching out of the box, so typically what you have is clients. So like it's not in our client, for example, in Java, but if you're in a browser, then basically, most likely, you're going to be using a client that also does caching. And that's really where things get a little more complicated, but clients should be handling that. Then there is the question of schema composition, which is not something you think about initially, but when you get into GraphQL, and if you're doing microservices, then eventually you will run into this issue where you will want different teams producing different parts of the schema, and then you want to somehow combine those together into a single schema. There is no standard in GraphQL around that. There are two main techniques. One of them is called federation, where there is a kind of mini spec that's created where a GraphQL gateway can take requests for data, so clients are generally unaware that there are different parts of the schema. But there is a gateway, and that gateway will then translate to each service in the backend to translate the incoming query and split it out as needed. But there is an extra syntax, and what flows between the gateway and those individual services isn't actually standard GraphQL. So there's a bit of an additional overhead there in complexity. And then there's also the stitching part where the individual participants aren't aware of the fact that something is being done for them to be aggregated. But again, this isn't an easy problem to solve, and many companies run into that. So that's generally a topic. So certainly don't look at it as a silver bullet. It brings a lot of interesting capabilities. I think you'll agree that, you know, the fact that you can declare a schema, you can focus on data design, granularity, you have a selection set mechanism. Those are all very interesting things, and there's a lot of tooling, and we don't have the time really to go through that. I wanted to provide as much context as possible, but as soon as you have a GraphQL engine, GraphQL application running, you can go into a GraphQL page, UI, and you can type your query with code completion, and then you can get the result. You can start experimenting. So, for example, GitHub, for their API, they use GraphQL now, in addition to REST, and you can, that's one way that you can explore a real-world API through this kind of interface. But I think in the end, the power that is afforded is worthwhile, but it is a journey. It isn't going to be where, you know, all your problems are now finished and you have no new problems. You will have new problems, but it is an interesting option to consider that makes a lot of things possible that aren't otherwise. I can't really speak about when it might be or not be appropriate to replace REST with GraphQL. I think that's a kind of a complex question, and it's not a, I don't think it's a binary answer. So I'll skip on making these kinds of recommendations, but I can just say that generally, I don't see that GraphQL does things that are going to inherently be inappropriate. I think it's a good idea for public APIs, but it comes, of course, with new challenges and problems that also need to be dealt with. So in terms of what's coming after, we just released 1.0. In 6 months is Spring Boot 3, which is a bit not ideal timing for us because it would normally require us to go to another major version, but we don't want to do that in 6 months. So in 6 months, we're planning to release something which is compatible with Boot 3. So you can run it with Java 17 and 19. It's going to be migrated to Jakarta EE, but it isn't going to require Spring Framework 6 or Boot 3. And then version 2.0 in 12 months is going to be, most likely, is going to be a baseline of Spring Framework 6 and Java 17. And that is everything I wanted to cover. We have about 5 minutes for questions, I think. Yes, you raised your hand earlier. I think there's a mic coming.
Yeah, I was saying that I think you mentioned the problem a bit after I raised my hand today, but if you're exposing schemas and that probably generate graph, my question is, probably you will going to have the n+1 problem of fetching. That is a common problem on Hibernate, for example.
Yes.
How can you avoid that? Because
yes, so there is the n+1 problem, and I didn't include slides on that, but there is a solution for that. There is a data loader mechanism, which, in a nutshell, it allows you to load related entities or objects through a class that manages, when it sees things that have already been loaded, it avoids loading them again. So it maintains a cache, and it also defers individual loading of related entities until the end, and then it loads all of them together. So you have to give it, let's say you have a user and GitHub profile. If you're loading many users, it will remember that you're trying to load the GitHub profiles for that many users, and then it will do a kind of a joined all of these, get me all of these IDs. We have a method called batch mapping in addition to the schema mapping, and that actually allows you to quite easily get, instead of a single user for the parent object, you get a list of users for the parent object, and you return a list of profiles. So there is a way to deal with n+1 problem. Yeah, thanks for mentioning that. Some more in the front here.
Hi.
Can we have the mic over here?
Sorry, I was probably closer. What about the versioning, schema versioning and the API versioning? So if I downstream service migrates to the next API and changes actually the structure, how GraphQL manages this, or are there any best practice for this?
Yeah, I think schema versioning is actually one of the nice aspects in GraphQL. Because you can evolve the schema in ways that aren't going to impact clients. And you can also provide ahead of time new things that are going to migrate to and support both of them at the same time. So, so there are techniques for managing that without breaking existing clients.
Yeah, can I ask a question, please?
Yes.
What do you think about code-first approach instead of schema-based approach for smaller projects?
Yeah, so we support schema first. That's what we focus on in Spring for GraphQL. Generally, we think that the schema should be central to the process. It should be something which is discussed with all the stakeholders, with the business, product managers, everybody who needs to be involved. And that is something to be treated as like its own artifact, not to be generated from code. you know, maybe in a small project, maybe. I'm never going to say it's never appropriate. But personally, I don't think it's manageable to think about this as kind of like being derived from annotations, and then you can, I mean, you can only generate it and then show it to a business person, but I don't know. I think it's much better to start with the definition, use that as the basis of discussion. You can check it in, you can see the changes, the commit history, how it evolves, and so on. So it's like a first-class document that you're treating, and then from it, I don't think it's that difficult to do the mappings, as you can see.
Thank you.
Yeah. There's one on the front row here.
Hello. In case your model is close to your database model, especially if you are working with traditional relational database, SQL-like databases, are there any kind of tools to translate your GraphQL model to a SQL query, for example?
So if you go back to if you remember the slides where I talked about Spring Data, Query DSL, and Query by Example, so that's one way to do it, because that, as you could see, it's just a book repository. You're declaring that it is a JPA repository and a Query DSL executor, and then, you know, that does all the work. Yeah, and it can even take the GraphQL arguments and turn that into a Query DSL predicate, which then will do the querying. Yeah. But yeah, I mean, generally, you can think of GraphQL and what we aim to do, same things that you would do in a web application, in a regular web application, we try to expose this through GraphQL. So you can imagine you control a layer calling Spring Data repositories even directly, like not necessarily relying on this automated registration and doing all the things you normally do in the data layer, but just exposing them through this. So it really doesn't change things from that perspective. We're just trying to make sure it's well integrated for GraphQL as well. I'm so glad I got this hat. Okay, well, thank you very much for sticking around, and enjoy lunch and the rest of the conference.